On our previous lecture, we have discussed and answered some problems regarding the bearing capacity of a single pile. In this video, we are about to discuss and answer some sample problems with regards to group of piles. In most cases, piles are used in groups, as shown in this figure, to transmit the structural load to the soil. A pile cap is constructed over this group of piles, and the cap can be in contact with the ground, as in most cases, or well above the ground, as in the case of offshore platforms. So in order for us to compute the group efficiency of this group of piles, we have this equation. Eta is equals to Ug over the sum of Uu. So eta is the symbol for the group efficiency. Ug is the ultimate load bearing capacity of the group pile, and Uu is the ultimate load bearing capacity of each pile without the group effect. So in some references, we have also a derived equation for the efficiency of group. So if the spacing is the same for this group of pile and as well as its diameter, we can use this derived equation, as you can see here on the screen. So the value of m here is the number of columns in plan view. So in this sample problem or sample figure, we have 3 columns, and for n, that's the number of rows. This is 3 rows, and s is your pile spacing center to center. D is the pile diameter. Now, in order to compute the ultimate bearing capacity for a group of pile, we have 2 cases. The first one, if the piles act individually, we can simply solve the ultimate bearing capacity of group piles by simply determining the ultimate bearing capacity of a single pile. Then you just multiply it to the number of piles. So if our piles for this group pile are identical, so we just simply determine the ultimate bearing capacity of one pile and just multiply it to the number of piles. That's for the piles acting individually. Now, the second case is if the piles act as a block. So it means that this group of pile is acting as a single block, which means that we will consider all of these piles as a single block, extending it on each edge, forming a rectangular shape. Okay, so that's in plan view. We can form a rectangle or a square, okay, based on this group of piles. So that will be the block for this group of pile. So that's why we need the dimensions, this one BG and this LG. Okay, so that's the edge to edge dimension for this rectangular shape, which is formed from this group of pile. So in this section, we can see this as a rectangular prism. So this will be your group of pile as a block. Okay, so we consider this as a single pile forming this shape. Okay, so same solution applies in determining the ultimate bearing capacity of a single pile, only that for the pile acting as a block, we consider this group of pile as a whole and as a single block. So it means this is your full area for the end bearing capacity, and this will be your area of concern for the skin friction resistance. So using the formula again, Qu is just the sum of end bearing capacity and the skin resistance, where we have the formula for Qb, which is just equals to the same solution as discussed previously, where we need the area of the end of the pile, which is in contact with the soil. So that area will be your cross section right here, which is just the product of the BG and LG. That's why we have this equation. The same way with the skin friction, um, as we have recalled, we have a CUPL, or this will be your perimeter, this will be the length. So for our perimeter, um, if this is a rectangular cross-section, your perimeter is just twice the value of BG is added to twice the value of LG, or simply just add all these uh, four sides of this rectangular shape formed by this uh, block. So also multiply L, the length of this group of pile. So that's how this solution is derived. So by concept, they have the same solution for a single pile, only that for the pile acting as a block, we consider this shape as a whole for this group of pile. Okay, next, let's now solve some sample problems with regards to this topic. So here's the problem. This is taken from CE Board May 2014. A 9-pile group consists of 0.3 meter diameter friction concrete piles 12 meters long. The piles are driven into clay having an unconfined compressive strength of 180 kilopascal. The unit weight of the clay is 18 kilonewton per cubic meter. The spacing of piles are 0.75 meter center to center, assuming a bearing capacity factor of 9 and the unit of skin friction which is equals to 1. Determine the following. Number 1, find the allowable group pile capacity based on individual pile failure using a factor of safety of 3. Number 2, find the block capacity of pile group using the factor of safety of 3. Number 3, find the minimum pile spacing in order to achieve 100% efficiency. So let's start. For number 1, let's write first the given. We have a given unconfined compressive strength QU, which is 180 kilopascal. So from that we can determine the cohesion of the soil by dividing the QU by 2. So 180 kilopascal over 2, that will be 90 kilopascal. That's our cohesion. NC 9, alpha 1. So unit weight of clay will not be used in this problem, and we have a spacing of 0.75 meters center to center. Okay, for required number 1, based on individual pile failure, we are required to determine the allowable pile capacity of this group of pile. So let's determine this one. So for individual pile failure, so what we need to do is to determine the ultimate bearing capacity for each pile and multiply it to the number of piles. Okay. Then to determine the allowable or the design bearing capacity, just divide this. Let's put G for group of piles. Divide this by the factor of safety. Okay. So let's now determine the ultimate bearing capacity for a single pile. So QU is equals to QB plus QF. So now for the end bearing capacity of a single pile, we had a formula of NCU area of the pile. So substituting those value, we have 9. Do we have a given diameter of pile here? Okay, we have a diameter of 0.3. P is 0.3 meters. So Cu is 90 kilopascal or kilonewton per square meter, and the area of the pile is simply pi d squared over 4, for the cross-sectional area of a single pile. So pi multiplied by diameter 0.3 meter square over 4. Okay, so we can now determine the end bearing capacity of a single pile. That's 9 times 90 times pi 0.3 squared over 4. Okay, so that's 57.255 or 256. 256, that's in kilonewtons. Next, for the skin frictional resistance, UF, we have a formula of alpha Cu P times L. So alpha, or the unit of skin resistance, is equals to 1. Cu is 90 kilonewtons per square meter. The perimeter of a single pile, of the cross section of a single pile. So since it's a circle, pi d. Okay, that's pi times d. 0.3 meters, that's your perimeter, and the length is equals to 12 meters. Okay, so we can now determine this frictional resistance. That's 1 times 90 times pi 0.3 times 12. Okay, this will be equal to 1017.876 kilonewtons. So just add the two. Okay, QB plus QF, 57.256 kilonewtons plus 1017.876 kilonewtons. That's your QB. Okay. 1075.132 kilonewtons. That's the ultimate bearing capacity. So for a group of pile acting as individual piles, we just multiply this by the number of piles. So 1075.132 kilonewtons multiplied by 9 piles. So this will be your equivalent capacity of this group of pile. 9676.188 kilonewtons. That's for question number 1. Okay, so since the required is allowable group pile capacity, this is just the ultimate. This is not yet the final answer. So we have to divide it by the factor of safety for the design or allowable bearing capacity. So divide this by factor of safety, 1.88 kilonewtons divided by 3. So the allowable is equals to 9676.188 over 3 equals to 3225.396 kilonewtons. So this is the allowable. Okay, this is your final answer for number 1. Okay, for problem number 2, find the block capacity of the pile. Okay, using the factor of safety of 3. So same approach, block capacity naman. Wait. For number 2, so this will be your block. This one, this one. Okay, this will be your section. So the dimensions of that block would be equals to, so if we have a 7.75 spacing for each pile for this row, so that has a total of 1.5 from center to center, so we have to extend it with the radius of this of each pile, okay, on each side. So this will be, so if we have 0.3 diameter of this pipe, so half of that will be extended to reach this edge of this block that we're going to form. So that will be 0.15 on each side. Same goes with this uh, side for this dimension of this rectangular block. So we just add up 0.15 on each side, or a total of 0.3 for each dimension. So that would be 1.5 meter plus 0.3. Same goes to the other side. Just add 0.3. So we have a total of 1.8 meters. 1.8 meters. That's the dimension of this uh, rectangular block. So now for the allowable for a group of pile, let's put B as a block. Okay, that will be QU over factor of safety, where QU is QB plus QF. So QB is equals to NCU area of the pile. So for the area of the pile, we have a shape of a rectangle. Okay, so N is 9, Cu is 90 kilopascal, and the area of the pile is 1.8 by 1.8. So QB is equals to 9 times 90 times 1.8 times 1.8. That's 2624.4 kilonewtons. For QF, we have ACUPL. So alpha is also 1. Cu is 90. P, the perimeter, or since this is also a square in shape section of the pile group or the block formed, so just multiply 4 for each side. 1.8 times 4, then, or simply add the 4 sides. 1.8. Then the length, total length is 12. Okay, so QF is equals to 8 times 12. Okay, so 7,776 kilonewtons. So the QU is equals to 2624.4 kilonewtons plus 7,776 kilonewtons. That will be equals to 10,400.4 kilonewtons. So the allowable for a group of pile by block, okay, block capacity, I'll just put B symbol, is equals to 10,400.4 kilonewtons to be divided by the factor of safety, which is 3. So okay, divide this by 3. Our answer is 3,466.8 kilonewtons. So here is your answer for question number 2, which requires the block capacity of pile group. Okay. Number 3, find the minimum pile spacing in order to achieve 100% efficiency. So number 3, we are required to determine the spacing given that we have an efficiency of 100%. So going back to our lecture, this is the equation that we're going to use to determine the efficiency of the group of pile. So 2 multiplied by m plus n, this is minus 2 multiplied by s plus 4 times d all over pi d mn. Okay, so let's rewrite that formula here. 2 times m plus n minus 2 times s plus 4d all over pi mn times d. So m is the number of column, n is the number of rows. So we have three columns and 3 rows. So this is 3 and 3. The diameter of pile is 0.3 meter. And that's it. So let's solve now. For 100%, that will be 1 equals to 2 multiplied by 3 plus 3 minus 2, the variable s, plus 4 times d 0.3 meters all over pi times 3 multiplied by 0.3 meters. So I will directly solve the s, the variable, using our calculator. So 1 is equals to 2 times 3 plus 3 minus 2 times the variable s plus 4 times d 0.3 all over pi times 3 times 3 times 0.3. Okay, so let's solve this. The answer for the spacing, minimum spacing, is 0.91. Okay, 10 meters. So here is your final answer for this question. Okay, so that's how we solve problems for group of piles.